Hey guys, I'm Mrs. Millsap, and in this chem tutorial we're going to be talking about the properties of matter and changes in matter. The first thing we're going to be talking about are changes in matter, and there's two types of changes that matter can go through. Remember, matter is anything that has mass and takes up space. Okay, so any object in our physical world can undergo two types of changes. They can undergo physical changes and they can undergo chemical changes. So what are physical changes? Physical changes are essentially changes that occur in the substance but do not change the actual chemical structure of that substance. So the identity of our substance will stay the same in a physical change. Typical physical changes that we hear about the most often are phase changes, okay? And a phase change is anytime it changes from one state to another. So for example, if we have water vapor that's in a gas state and it cools, that would be an example of a phase change. Okay, so I'm changing from the gas state to the liquid state. Keep in mind that physical changes may look like a different substance, but the actual chemical makeup of that substance is not changed. So it may look like it's changed even though the actual molecules are still the same. A couple examples of physical changes. These are all really great words to memorize. Maybe put them on an index card and label it physical changes, because you're going to see these words in your test and in labs. And all of these words are examples of physical changes. Grinding a chemical. So if I have a solid and I'm grinding it up into a powder, that's not really a phase change, but it's kind of like a phase change in that it was a solid and now it's turned into kind of a different state. It's now a powdered solid. So if you change the way it looks on the outside, doesn't mean that my particles are any different, right? So I can grind something up and it's still the same substance. Just like I can grind up sugar cubes into small, teeny little sugar particles, but it's still sugar. Cutting paper. If I cut paper in half, if I just cut this in half, it's still paper. I may have two sheets of paper, but my identity of my substance has not changed, even though it looks different. Melting metal. If you have a metal and you melt it, it goes from a solid to a liquid. That's a phase change, so that means it's physical. Boiling water is a phase change. Condensing vapor into water, that's going from the gas to the liquid state. Again, that's all phase changes. Another good word I wanted to put down was diluting. Diluting or mixing. You can mix two chemicals together and they can still hold their separate identities. For example, if I have salt and I have water and I pour the salt into the water and I mix it up, it may look like I've made something new. We call that salt water, but really all I've done is I've taken salt molecules and I've put them next to water molecules. But I still have salt and I still have water. Even though they're next to each other, they haven't formed anything new. These are the two questions I always ask myself if I'm not sure whether it's a physical change. Is the substance still made of the same chemicals as before? If the answer is yes, then it is a physical change. You can also ask yourself, was the only change that occurred that the substance changed to a different state of matter, aka a phase change? Again, if the answer is yes, that means it's a physical change. Okay, let's move on to the second type of change. This is a chemical change. And a chemical change is essentially a change that occurs to the substance that makes it no longer the same substance. I also describe it as a new substance has been formed. Okay, so here are some examples of chemical changes. If gas or smoke is produced, then that's an example of a chemical change. The only difference is that if gas is produced because something's boiling, that's not a chemical change, because those bubbles still hold the same exact molecule, it's just in a different state. However, if a new gas or new smoke is produced, then that would be an example of a chemical change. Same thing with bubbles. If new bubbles are produced. For example, if you take baking soda and vinegar and mix them together, they produce a bunch of gas that comes out in bubbles, but that gas is not baking soda and vinegar vaporizing, it's actually a new substance called carbon dioxide. So if I'm producing a new type of gas, then through bubbles, then that's a chemical change. If there's a color change, that's an example of a physical change. That means a reaction's taken place. Or if you form anything new, you could form a solid. Solids are also called precipitates. Precipitate. So if a precipitate or a solid has formed, then that's going to be an example of a chemical change. And here are some key words. There's a bunch of them, like rust, oxidize, form, tarnish, produce, ferment, rot, explode, corrode, burn. Remember, another word for corrode is erode, so you can see that word too, and that also means that a chemical change. All of these, essentially what they mean is that our substance has reacted with something and formed something new. Our substance has reacted and formed something new. These are great key questions to ask if you're unsure if it's a chemical change. The first is there something new formed? If the answer is yes, that means it's a chemical change. Did the substance react with anything? If it reacted with anything, or if you see the word react, then we know it's a chemical change. And then, was there smoke or any other substance produced? And the key thing is not just any substance, but a new substance. If the answer is yes, then that's a chemical change. Okay, let's do some sample problems. So what I'd like you to do right now is go ahead and stop the video, and I want you to try to do these 18 on your own, and then I'm going to go over the answers to these. So go ahead and pause the video now. So if we look at the very first one, it says glass is breaking. Remember, if we have a substance and we break it into smaller parts, it's still the same substance, so that's a physical change. Hammering wood together. If I take two substances and I put them next to each other, but they don't form anything new, that's a physical change. A rusting bicycle. Rusting is a key word for a chemical change. Melting butter. Melting is a key word for a physical change. That's just that our butter is now changing state from solid to liquid. What if I separated the sand from the gravel? If you had a lot of time on your hands and I gave you a bunch of like dirt and I told you to separate every sand particle from every gravel particle, all you're doing is you're physically changing the look of the dirt, but it's still sand and gravel, right? So it's a physical change. Bleaching your hair. That causes your hair to totally change color, right? And color is a key word for a chemical change. What about frying an egg? Well, if I add heat to something and it's now changed its substance, then that's a chemical change, right? What about squeezing oranges? Well, if I squeeze an orange, all the orange juice was inside the orange, and now it's inside a glass. So even though it's changed its location, it's still orange juice. So it's physical. Melting, again, is a key word for a physical change. Now, a couple of the other ones. Burning and exploding are all examples of chemical changes, and everything else is going to be a physical change, okay? Because it's not actually changing the substance. So all of these are physical. Okay, the next thing I'm going to talk about are properties. There are two types of properties of matter. You have physical properties of matter, and those are just a property of a substance that can be observed without changing your substance at all. A chemical property is something that you can only observe if it reacts. That's super important. You can only observe a chemical property when it reacts with something else. For example, a chemical property could be how it reacts to air, or how it reacts to water, or the amount of heat that it produces when it does react. Okay, so chemical properties, the biggest key word is that it's a property that you have to observe when it reacts. Pretty much all other properties are physical properties, meaning that you can observe them without changing the identity of the substance. This means that I can observe physical properties through a physical change. You can observe physical properties if it undergoes a physical change. For example, boiling point is an example of a physical property. I can observe, I can measure the boiling point of water without actually changing the identity of water, right? I can boil water, and that's just a physical change. Those are some examples for physical properties and chemical properties. Now, there's two types of chemical properties, okay? There's intensive properties, and then there's extensive properties. An intensive property is something that will always stay the same no matter how much of that substance you have. For example, the boiling point of water will always be the same no matter if I have a gallon of water or a cup of water, okay? The color of water will always stay the same no matter if I have a gallon or a cup, right? Extensive properties are properties that change with the amount. For example, the volume of water will change if I have a cup versus a gallon, and the mass of water will change depending on whether I have a cup or a gallon. These are pretty much the only two extensive properties that we'll talk about in this class. Everything else is pretty much an intensive property. So here's an example. Extensive just means that the amount matters, all right? So if I told you that this cup had, let's say it weighed 250 grams, okay? But this pool weighed 250 tons. This value changed, right? And so since it changed with the amount that I had, it's an extensive property. Same thing with volume. I might have 250 milliliters here, whereas I may have, I don't know, 250 gallons of water in the pool. Okay, so volume and mass change depending on the amount you have. And that term is extensive, okay? Intensive is something that's like a part of the substance. It won't ever change. For example, an intensive property about me is that my name is Allison, okay? That's never going to change. An extensive property about me would be my clothing size. That would change depending upon how big or small I am, right? But something about me, like my name, is going to stay the same. So intensive is kind of inside the molecule. It's a part of what it is. Some examples of intensive properties would be like the color of water, density will always stay the same no matter how much you have. What about viscosity? Viscosity is how the liquid flows. It doesn't matter if I have a bunch of liquid or a little bit, it should flow the same way. Any kind of boiling point or melting point are other examples of intensive properties. And that's it for this chem tutorial. Y'all have an awesome day. Get excited because you're finished with the last chem tutorial of this unit. So give yourself a pat on the back and a thumbs up and move right along.